Okay, so 7.70, there is no energy stored in the circuit at the time the switch is closed. It first asks us to find IT, and then it's going to ask us to find V1T and then V2T. All right, so let me go ahead, analyze the circuit, right? We know the drill. We make this bottom node our ground. You know, this is 80. Short the circuit here. I'm going to call this VT. And call this V2. Okay. And this is for t greater or equal than 0. Right. So there's no KCL, no separation of current here. Current follows one path. So our equation for component would be IT equals to 80 minus VT over 40. Another equation would be VT minus V2T equals to 5 DI T over dt minus 2.5 di t over dt. And then we got, which will, this we can just go ahead and say 2.5 di t over dt. We can go ahead for our second one, our v2t. We know that v2t is equal to 10 di t over dt minus 2.5 di t over dt. Right, so, and then we know this is 7.5 di t over dt. Okay, so now that we have our equations here, you know, our variables, we want to find our IT, V, T, V2, T. In case we would want to plug this into Maxima. But there's really no need. So first thing we want to do, we could either find the equivalent inductance, or we can go ahead and replace, plug in this V2T into this equation. I'm going to avoid doing the equivalent inductance just so you see another way of how to solve this. So yeah, VT minus 7.5 di t dt is going to be equal to 2.5 di t over dt. So VT is going to be equal to 10 di t over dt, right? So yeah, then we can go ahead and replace this into this equation, our first equation for our current IT. We can go ahead and place that. So we know IT is equal to 80 minus 10 di t over dt over 40, correct? So then we can go ahead and say 40 di t, or no, 40 times it. 40 times it plus 10 di t over dt equals 80, right? Let's steal this really quick. Okay. You know that. And oh, I also know that. And we also want to write down this equation right here. It's going to be I'm going to find this really quick. I usually don't memorize these. Just keep them on a note card. Helps. Yeah, dy t plus yt over tau equals, okay. Okay, so these two look similar. So what we're going to do is we're going to go ahead and this we can find, we can say it plus 10t, yeah. So we t, actually, what am I doing? Simplify this. It's going to be it over 4 plus di t over dt equals 8. So k is 8, tau is 1 over 4, right? So if we know our k and our tau, we can go ahead. We also know that tau times k is going to be our, well, in this case, our I infinity would be tau over k, right? So infinity would be 1 over 4 times 8, 2 amps. And our I at time 0 would be 0. Okay, so then we can go ahead and replace such. I infinity 2 plus 0 minus 2 e to negative 4t. So it'd be 2 minus 2 e to negative 4t would be our function for our current it. Now what we got going is we want to find our v1. Oops. Wow. Yeah, whatever. We can ignore this. So v1, right? So we know v1 t is going to be equal to vt minus v2t, right? And now essentially what we want to do is solve for v1t. So we know vt is equal to, I think, 10 di1 dt. Yeah, 10 di dt, I mean. Minus v2 t is equal to 7.5. v1t is going to be equal to 2.5 di1, or I keep saying di1, so I won't current. Dit over dt. So then we can go ahead, say v1 t is going to be equal to 2.5 times, we want to find dit over dt would be the derivative of it. So we get 8e to the negative 4t. E to the negative 4t. 16 plus 8, I think it's 24. No, 20. 20. It's so v1t would be 20 e to the negative 4t for time greater or equal than 0. And so, yeah, so this is our answer. Now we want to do v2. We know that v2 is 7.5 dit over dt. So 7.5. So yeah, 8e to the negative 4t. 7.5 times 8. That'd be 7.5 times 8 is 60. 60e to the negative 4t. And these would be in volts as well. So yeah. I believe our conditions are satisfied. Part D, it's kind of, it's pretty easy to notice that at time 0, if we know our original voltage is 80 volts, even at time 0. So if we were to put the function of Vt at V1t at time 0, it's 20, 60, you add these, 80, 80. So our KVL is satisfied here. So yeah, this would be our answer for 7.70.